In this video, we're going to look at how to write equations of hyperbolas given certain information. So here's a reminder of the different parts that are in a hyperbola, and we might reference this throughout as we go through a few different examples. As you see highlighted already here, we have this value c. That's an important one, which it doesn't show the whole thing. C is that length, but more importantly, it is the distance from the center to the focus, and that's written over here. Also, we have the center, we have our vertex, or the endpoints of the transverse axis, and the transverse axis is the one that crosses through the hyperbola. It hits the hyperbola at its two vertices. And then we have the other axis here, the conjugate axis. That is the one that doesn't touch the hyperbola, but it's still an axis of symmetry, so that's called the conjugate axis. We see the reference rectangle is what is used to help us find our asymptotes. And then we have the equation a squared plus b squared equals c squared, and that has to do with our equation of an ellipse, of a hyperbola, where a squared, the value of a, or a squared, is what's under the first fraction, which is the way it's oriented. So this one is opening left and right, so x comes first. And then b squared is under, in this case, the y. The a here has to do with, and this might be helpful, the a has to do with your vertices, the distance from the center to the vertex, and b has to do with the distance from the center to the endpoint of the conjugate axis. So let's go ahead and look at some of these examples. So in the first one, the vertices of the hyperbola are -1, -2, and -1, -12. Once again, just like the ellipse, we are going to start with just this equation of a hyperbola. Now we can't fill this out yet with x and y quite yet, because we don't know if it's a vertical or horizontal facing hyperbola. So we don't put that in there quite yet, but these are the things we want to fill out, and that's one of the things we'll decide or figure out right away. So remember, we want four things here. We want the x value of the center, the y value of the center, we want a, or a squared, and we want b, or because we need to know b squared, and we remember the equation, we might need to use a squared plus b squared equals c squared. So let's go ahead and look at this one. The vertices are at -1, -2, and -1, -12. We can graph this, or we can think through this, but I'll go ahead and sketch the graph just so I can point to stuff. With -1, -2 would be about here, -1, -2, and then -1, -12 would be down here. So that's the vertices. That's going to help us find our center. Our center is going to be right here. It also tells us that this is a vertically facing parabola, hyperbola, which means the y value comes first, and then x will come second. So the fact that it's vertical means your y value is first. So this center point, we know it has to be left 1. So left 1 means we would put a +1 in here with the x. And we also think what's halfway between -2 and -12, which is -7. Another way to think about that, from -2 to -12 is 10 units. So split that in half. That's 5 units, and that 5 is important. So this distance is 5. So this point has to be -1, -7. which since it's down 7, we put a plus 7 in here. While we were doing that, we found this important value of 5. That's the distance from the center to the vertex, which remember from center to vertex is our A value. Now this one here is a horizontally facing one. This is vertical. So the A goes under the Y. So that's 5 squared. So we have 3 of the 4 things. We have the X value of the center, the Y value, and A. We need to find B. Well, we're also given the endpoints of the conjugate axis are 9, negative 7, and negative 11, negative 7. So 9. So we're coming all the way out here to 9, negative 7, and negative 11, negative 7. Well, these are the endpoints of the conjugate axis, which means the center to the endpoints of the conjugate axis, this value is B. So they're both that Y value of negative 7, so what's the distance from negative 1 to negative 11? That's 10. To check that, what's the distance from negative 1 to 9? That's also 10. So B equals 10, which means 10 squared goes here. Don't let that confuse you. In an ellipse, not a hyperbola, in an ellipse, A has to be greater than B. But in a hyperbola, A does not have to be greater than B. So there is the equation of the hyperbola with that given information. Number 11 would be similar. It gives you that the conjugate axis is 4 units long. So a little bit different than the endpoints of the conjugate axis, but that just means B will equal 2 units when you get to that point. I'm not going to go through 12 completely, but that should get you started. Let's take a look at number 13. 13, again, we're dealing with a hyperbola. So let's go ahead and write our fraction equal to 1. And we'll have to figure out if this is vertical or horizontal. We're going to find our 4 different things. Once again, our X value of the center, the Y value of the center, the value of A, and the value of B. All right, so we have our vertices. Our negative 2, 7, and negative 2, negative 9. If you've been thinking through this, you're going to realize that if the X values are the same, this is going to be a vertically facing hyperbola, and that same concept works with ellipses also. But if we're at negative 2, 7, and negative 2, negative 9, we definitely see that's a 7, this is negative 9. This is going to be a vertically facing hyperbola, which means, so vertically means that the Y value is first, or Y comes first. So we need a Y here and an X here. With this, we can easily find the center. What's the distance from 7 to negative 9? Well, that distance is 16. So that's this whole distance, which means from those vertices to the center is going to be 8. So this distance is 8, and that can help us find this value. If we go 8 units down from 7, we're going to be at negative 1. So our center is at negative 2, negative 1. Again, Y came first, so we do Y plus 1, because that has to do with the 1, and then X plus 2. While we were doing this, we found this other important value, 8, which is A, because that is the distance from the center to the vertex. So A squared goes here. We filled out 3 of the 4 things. We still need to find B. Here it gives us the perimeter of the central rectangle, or I've been referring to this as the reference rectangle. So if that is 48. I could draw it in this figure here, but it's pretty messy already. So let's just sketch this again. So we're going to have 48, but we know this length is 16. So we have a 16, and we're going to have a 16 somewhere else. This isn't going to be drawn to scale. 16 over here as part of our reference rectangle. Well, if we have a perimeter of 48, and we subtract the 16 plus 16, which is 32, we're left with 16. Now be careful, that's 16 left for this part and this part. So we do 16 divided by 2 is 8, and 8 is going to be this length and this length. Well, thinking through that, this whole length is 8. We don't want the whole length of the reference rectangle for B. The value for B will be half of it. So B is going to be equal to 4. So we can put 4 squared there, and there's the equation of the hyperbola. Let's go ahead, we'll take a glance at number 14. 14 gives us the focus points and the asymptotes. Let's go ahead and do this one. So focus points are at 3, -5 plus root 73 and 3, -5 minus root 73. We know this is a hyperbola, so let's go ahead and get started with our equation. We'll need to find 4 pieces of information. So let's go ahead and start with this focus. The focus, we're going to just sketch the idea to help us out. We have 3, and then -5 plus root 73. Root 73, what is that? The square root of 64 is 8. The square root of 81 is 9. So we're at 8 point something. 8 point something. So I did that just so we can reference this. So -5 plus 8 point something. That brings us up here to 3 point something. And then for our other point of the focus, the other focus point, we have 3, -5 minus the 8 point something. So that's going to bring us to -13 point something. Well, looking at that, we see that this is going to be vertical. Once again, we have a vertical facing ellipse, so y is going to come first. Parabola, not ellipse. I mean hyperbola, not ellipse. So y comes first, and then x. We can pretty easily find our center because we're at 3. -5 is halfway between those two focus points. So the center is at 3, -5. So the y value goes with y. That's y plus 5 and x minus 3. Okay, a couple things that I taught you before, but that I didn't mention in this figure right here. We have the asymptotes, and earlier I told you the slope of the asymptotes are going to be plus or minus b over a. b over a if it is a horizontally facing hyperbola, but if it's vertical, your b and a are switched. So it's going to be plus or minus a over b for vertically facing hyperbola. The other thing is that eccentricity is c over a, which is a ratio, but it will help us find some missing parts there. So coming back to the one we're talking about, this is our distance from the center to the focus, and that's root 73. So root 73 equals c. That doesn't help us fill in a or b right away, but it may help us as we work through this. We have the equations of our two asymptotes. And so we know that our slope, one of them is 8/3, one of them is -8/3. Our slope is 8/3, which we remember, which I just mentioned, since it's vertically, it's going to be rise over run, so it's going to be A/B. Now, it might be, and it looks like it will be, that it's actually 8/3. Remember, this is just a ratio, so to get 8/3, it could have been 16/6. But if you notice here, we mentioned earlier, the distance from the focus to the center, focus to center, is C, and that's root 73, and the distance from the vertex to the center will be smaller than that. So this C was 8 point something, so it seems like this A value will be just smaller than that, which will be 8. So we can know that 8 is A, so this is A squared, and B is 3 squared. And so there is the equation of that hyperbola. Our last one here has a center at -6, -9, one focus point, and then eccentricity. So let's take a look at this. We know this is the form of our hyperbola. We know we want something squared here. We know our center, but we don't know which one comes first yet. So it tells us our center is at -6, -9. And that tells us a focus point is -6 plus square root of 157. That's 12 point something. In fact, let's just go ahead and find that. So square root, just to help us out here, of 157, about 12.5. That'll just give us a good reference. So 12.5, so we're going up 12.5-ish. So this is going to be about 3.5. The number doesn't matter all that much. What helps us here, oops, that I messed up right there. Sorry about that. So we want to go, that is not there, -6. So we're at -6. We're going to be down 9, but at this -6 we have to add 12.5. So I'm sorry about that. Adding the 12.5 puts us to about 6.5, and that's where our focus point is. So we're at -6 plus square root of 157 and down 9. Which, looking at that, if our center's here and our focus is here, that's our C value, is square root of 157. And also that tells us this has to be a horizontal hyperbola, which means x will come first, y will come second. Now that we know x comes first and y comes second, we can come to our center, plug that in. That's going to be +6 and +9. And now we're going to look at eccentricity. We know eccentricity is C over A. In this case, we know C is square root of 157. We don't know A. We don't know the distance from here to the vertex. But we do know eccentricity is square root of 157. Sorry, 157 over 11. So this tells us A has to be 11 because of this fraction right here. So A is 11. 11 is the horizontal, so 11 squared. We still don't have B, but we know that A squared plus B squared, let's not put it there, let's just come here, A squared plus B squared equals C squared. A squared is 11 squared. We don't know B squared, but we know C. C was square root of 157. So we square that. This is 121 plus B squared equals the square root of 157 squared is just 157. we will subtract 121 from both sides, which gives us 36. And actually, b squared is 36. So we put 6 squared there. And there's the equation of that hyperbola. So that's writing equations of hyperbolas. I only left you with one to finish up here for your assignment.